Okay, welcome to Virtual Science 2021 again. And you should have opened up this PDF on your computer and have it ready to go. If not, pause the video for a second and get it out so you can go over it with me. Okay. Now, today is kind of like the practical application of what we learned. We said that all mixtures can be separated. So whether a solution, a colloid, or a suspension, we can get the parts of the mixture apart. And because it's a mixture, there is no chemical change. So like when salt gets mixed in water, the salt is still salt and the water is still water. Now, this is kind of a big deal. In Virginia, we're very fortunate that we have a available supply of fresh water. But in a lot of places in the world, like California and the deserts of the Middle East, like in Saudi Arabia, where the Sahara Desert is, they don't have enough fresh water. But there's plenty of ocean water. So one of the things that people are building are plants called desalination plants. And they do exactly what their name says, is they desalinate, or they take the water, the salt out of the water, because they want pure water. So kind of an expensive process right now. So one of you, learns how to do a better job at separating the solution and purifying it, find a more efficient, cheaper way to do it. There's a lot of money to be made there. Also examples of in nature, when we find things, rarely do we find things that are already purified and ready for us to use. So even like when a farmer harvests wheat, what you want is the little part of the wheat that's the seed, but there's the stems and the dirt, everything else that got sucked up in the combine when they were harvesting the wheat. So they got to get it purified. When I was first out of college, I worked as a software consultant. One of my clients was a place called Orange County Sanitation District. This was in Orange County, California. What they did at the sanitation district is they took all the water from all the toilets in Orange County, which there's millions of people there, so poop water. And their job, so what are you going to do with all? You got millions and billions of gallons of, this toilet water. You got to do something with it. Well, what needs to be done with it is you got to get all the poop and the peat out of the water and separate it. And once you have this pure water, you can put it back into the ocean, into a river. So their job was to separate that mixture. So in real life, people, are doing this all the time, and the faster and the more efficient you can do it, the better. So we're going to talk about some of the ways that people do that. So on this page, it says, how can a solution be separated? Remember, a solution has the smallest particles, is completely dissolved. Light will pass through a solution. Okay, we got some things that you already know here in these terms. Condensation is the change of a gas to a liquid. Distillation is the process of, and then it uses two things you already know about. First, you evaporate the liquid, and then you condense it, and then evaporation. So we're going to talk about each one of these separately. Okay. A solution, a solute, which is the stuff that got dissolved, can be separated from a solution by evaporation. So down here they have this, it shows this copper sulfate solution, and what copper sulfate looks like is it looks like blue salt. You mix it in the water and it dissolves just like salt. And then they're showing us here that if you evaporate the water, you get back the copper sulfate crystals. So if this was salt water and we evaporated it, we would have salt crystals here. So it says it's a change of a liquid, the water, to a gas. The surface of the liquid, molecules of this liquid gain enough energy to break free of the liquid and move into the air as a gas, such as the water vapor is breaking loose and moving into the air as a gas, and what's left behind are the copper sulfate crystals. Now it says, suppose you wanted to separate copper sulfate crystals from a solution of copper sulfate water. You could place a solution in a salad dish and let it stand. After a few days, all the water would evaporate. Crystals of copper sulfate would remain at the bottom of the dish. How can salt be separated from the saltwater solution? Same way. And a lot of times this is actually how people get the salt that we use. They have a large place where they place ocean water in a shallow pool and let it evaporate, and what's left is salt. And then they got to purify that again, so there's more separating of mixtures. So again, people do this a lot in the world. Condensation, okay? You know that's when a gas turns back to a liquid. It says if you ever come out of a hot shower, find drops of water on your bathroom mirror. Drops of water are the result of condensation. So the steam was up in the air in the room, and the steam is water vapor, is a gas. So you had this water in its gas state. It hit the cool mirror, and it turned back into a liquid. So this condensation is the change of a gas to a liquid. Some of the shower water evaporates from the steam. When the steam strikes the mirror, it's cooled. This causes the steam to change back to a liquid. Now, distillation kind of combines both of these. It puts together the two things. So over here, you got this mixture of, let's say this is salt water. Okay? And you're building that desalination plant in California. What you want is pure water for the people to drink and to water the farm crops with. But you also like to keep the salt too, because you can sell salt in the grocery store. So you want to get back both the solid that was dissolved and the liquid. Okay, so it says distillation. Okay. A solution can be separated into its solute and solvent process, distillation. In this process of distillation, a liquid is heated until it evaporates. The gas is then cooled until it condenses back to a liquid. So what the little diagram here is showing is that they heat this, let's say this is salt water, they heat it and the water evaporates and goes up into this tube. Then it gets cooled in this tube right here. And it condenses back into a liquid, and the pure water comes out on the other side. What's going to be left on this side, when all the water is evaporated, is just the salt. So it says when a solution is distilled, both the solvent and the solute can be recovered. The solution to be separated is heated over here. The solvent, which is the stuff that did the dissolving, so the water, evaporates and forms the gas. Gas moves it to called a condenser, because that's what it does. It mixes gas and condenses it back to condensation, back to a liquid. Chases back to a liquid. The liquid drips into the container. The solute, the stuff that got dissolved, so like the salt, remains in the original container, and both the solute and the solvent are recovered. So what it's telling us is, we get all done. On this side, we're going to have salt. Like this was salt water. And that would be our solvent. And over here, the solvent, the stuff that originally did the dissolving, we would have pure water. Okay. Now, on a practical level, just beyond these desalination plants, when they pump oil up from the ground, it doesn't come out of the ground as ready for us to use. It doesn't come out and it's like unleaded and unleaded plus and high octane, and it's this brown goo. It's more like tar. So what they do in a refinery is they heat the goo, and the gasoline evaporates, and then each substance in there evaporates at different temperatures. So they heat it to where the gasoline evaporates, it's condensed, and they have gasoline. And then they do the same thing, it condenses, and they get kerosene. And then they do the same thing, and it condenses. They boil it, and it condenses, and you get diesel fuel. So they separate out the different products that we use from the goop that came out of the ground the same way. Okay. All right. And there's a slide in your study packet that corresponds to this. So you should refer to this reading and answer those questions, and we'll see you next time.